Alrighty, today we're doing 6.6, which is something called vectors. So we're out of polar form and now we're into vectors. So the definition is of the I and j unit vectors. Vector I is the vector whose direction is along the x-axis, and vector j is along the y-axis. So I just want to kind of summarize here what we know already. So if we're in our rectangular, which is what we've known for a really long time, our coordinates are x, y. And then what we started to explore this chapter was polar, which is r theta. And now we're going to learn vector, which vectors are written as ai plus bj. And a is going to be your horizontal component, and b is going to be your vertical component. So they're very close to rectangular, but they're written in this form right here. And since this is the intro one, everything's going to be pretty basic. So if you're going to be doing a vector from the origin to some point AB, this is how we write it. That's why I was saying the horizontal component is A and the vertical component is B. So this sum is a linear combination of the vectors I and j, and the magnitude is the square root of a squared plus b squared. So this is the symbol for magnitude. It's like a double absolute value bar. And if you look at here, here's the horizontal component, here's the vertical component, and then if you want to know the magnitude or the length of this vector right here, then all you do is use the Pythagorean theorem. Okay, so this example 1 says sketch the vector -3 plus 4j and find its magnitude. So to sketch it, this right here is the horizontal component. So I go 1, 2, 3, it's -3 on the x-axis. And then 4 is the vertical component. So I go up 1, 2, 3, 4. And it's coming from 0, 0. So it looks like that. Vectors do have little arrows on them. So it's not anything tricky. And then the question is, what is the magnitude of the vector? So again, on your test, I'm going to ask you evaluate this. And if you don't know what that symbol is, then you aren't going to be able to get it right. So I would make sure you study that notation. So here is me plugging into the formula, or just doing Pythagorean theorem really, and then solving for the hypotenuse. So the vector magnitude is 5. Okay, so example 2 is exactly the same. So we're going to go and graph this. So it's horizontal is 3, vertical is -3, so it's going to end up right there. And it's starting from 0, 0. They don't always start from 0, 0, but since this is the very first two examples, that's where we're starting from. And then to find the magnitude, we're going to do the same thing we did, and we're going to remember that we always simplify our radicals. Make sure you follow order of operations. So a radical underneath a radical is if things are in parentheses, so you have to do those. Okay, so super simple, right? It's like stuff we already know how to do. We're just applying it to a new form. So what happens if the vector is not starting at the origin? What if it's starting from point 1, which has coordinates x, y, and going to point 2, which has coordinates x2, y2? Well, this is what you do. In order to find the horizontal distance, you just subtract x2 from x1. And in order to find the vertical component, you're going to do y2 minus y1. So that's what that says right there. And because we're in vector form, we're going to put v equals, and then whatever the horizontal distance between the 2 points is going to be in front of I. And whatever the vertical distance is between the 2 points, it's going to be in front of j. So it says let vector v be the vector from this initial point. So this is x1, y1 to the terminal point x2, y2. So that's important to know which one comes first. And it just wants us to write the vector. So we're just going to go ahead and go v equals -2 minus 3, and then we have to have the I because that's vector notation, plus 5 minus -1 j. So just like a lot of things in pre-calculus, we learn the skills so that we can learn the applications in calculus. So we're not going to do a ton of stuff where we apply vectors, but when you get to calculus you will. So we're learning the basics right now, so you're not having to learn both in calculus. So this is going to be -5i plus 6j. All right, moving on. So example 4 is exactly the same. So you have x1, y1, and x2, y2. So you find the distance starting with the horizontal components and then subtracting the vertical components, and then just finishing that off. So it's a lot of intro stuff, so if you're doing flashcards you might want to make a couple more than just 4 just so that you get all that stuff done. If you practice the flashcards you're going to be fine on the test. It's just how well you remember. So we can do operations with vectors. So for example, we can add the vectors together. So if you have two vectors, let's say vector v and vector w, if you want to add them together, what this says right here is that you add their horizontal components and put it in front of I, and then you add their vertical components and put it in front of j. Or if you're doing subtraction, you do the same thing. You can also multiply the vector by a constant. They call it a scalar. You can see that word right there. So a scalar is just a constant. So if there's some number like 2 in front of the vector, then you just multiply both the horizontal and the vertical component by 2. So super straightforward. So this one tells us to add vector v to vector w. So the way that we're going to do that is we're going to first add their horizontal components. So that would be 11i, and then we're going to add their vertical components, which would be -5j. Then what we're going to do is subtract. So be careful with the double negatives. 5 minus 6 is -1, so I'm just going to write -i. And 4, I'm going to write this 4 minus -9. That's going to be 13. And it's going to be positive because of the double negative. This one is 6v, so that just means multiply the v vector by 6. So you're going to multiply the horizontal component and then the vertical component. Super easy, right? So we're going to do the same thing, example 6, just some extra practice. So add v plus w. It's going to give you 11i minus 2j. Then we're going to carefully subtract them, and we're going to get 3i plus 8j. Then we're going to multiply just v by -3, and that's going to give us -21i minus 9j. And perhaps the trickiest one here is this one. So you're always going to do the scalar first. So let's find that first. So I'm going to do 4 times v, so that would be 28i plus 12j. So there's that one. And then I have to subtract 2 times the w vector. So I'm putting it in parentheses because we need to subtract all of the the w vector. So that means that this negative needs to go to both. So if you don't put it in parentheses when it's going from one term to 2, you'll miss that negative. So that's going to end up giving us 20i, and that's going to be plus 22j. Okay, pretty straightforward so far. Like I said, vectors are pretty easy when you're learning the basics of them. Obviously, like any part of math, it gets more complex, but we won't be exploring that. There is something called the unit vector. So remember when we talked about the unit circle, it's because the radius was equal to 1. The unit vector, it has a magnitude of 1. So that means that when you do the Pythagorean theorem, the length of the hypotenuse is 1, which is just like the length of the hypotenuse in the unit circle. The r value is 1. So the way that you're going to create the unit vector is by this formula right here. Take whatever vector that you have and divide it by its magnitude, and that's going to give you a vector that has a magnitude of 1. So I'm just going to put memorize on that so that if I ask you to find the unit vector, you remember how to do that. In example 7, I've spelled it out for you step by step. So here's our vector v, and we first have to find the magnitude. So remember, the magnitude is just the Pythagorean theorem, or we're finding the length of the hypotenuse of the triangle created by this vector. And that gives us 13 when we do it. So then what does this say? Take your vector and divide it by its magnitude. So I'm going to use this notation, vector, like unit vector right there. So we're going to do 5i minus 12j, and then divide it by 13. And then we normally split up vectors. So you don't want to leave it as one fraction here because you need to see the horizontal component and you need to see the vertical component. And that's it right there. There's our unit vector. Makes sense for you to divide it by the hypotenuse so that you get 1. This part right here says then verify the vector has a magnitude of 1. So what is the magnitude? Remember, those double absolute values represent magnitude of this. Well, we're going to do 5 over 13 squared plus negative 12 over 13 squared. And that gives me 25 over, it should be 1 though, right? Like we recognize that we created a unit vector, so it should have a magnitude of 1. We're just verifying this right now to see that we did it properly. In your homework, if it doesn't say to verify it and it just says to find it, then you can just find it. You don't have to do this step. So there you go. We verified that it has a magnitude of 1. Alrighty. Moving on to example 8, this is the same exact thing except for I didn't spell it out. So the first thing that we're going to do when finding the unit vector is finding the magnitude of the given vector. I feel like we've been doing this magnitude a lot in this lesson, so you should be able to get the hang of this pretty fast. Then to find the unit vector, we have to take the original vector and divide it by its magnitude. So that one's a J there too. So there is my unit vector, and then this does prompt us to verify that magnitude of that unit vector is 1. So just more Pythagorean theorem, nothing too alarming. So you see me writing steps just defending my answer here. But if you went straight to 1 from that step, I would give it to you. Okay? Alright, the last little part of this is writing vectors in terms of its magnitude and direction. So this might seem like super annoying right here for you to have to memorize, but I'm going to show you how really it's something we already know and we've already been working with. So I am going to write memorize here just to help you out. But look, it says the horizontal component is the magnitude of the vector cosine theta. Well, isn't that the same thing as this right here? Take the radius and multiply it by cosine theta, and then the horizontal or the vertical component is sine. Right? So you're just adding those together to get your vector. Okay? So let's take a look at example 9. The wind is blowing at 20 miles per hour. So here's the tricky part. That right there is the magnitude of the wind. So you're going to make this right here your magnitude. Okay, so that's that. And it's blowing in a direction of north 30 degrees west. So here we go. So north 30 degrees is here, west, and it has a magnitude of 20. express the velocity of the vector v in terms of I and j. So here's the vector v right here, and here is our entire angle, right? Because this is the angle from the y-axis. That's how we do bearings. So step 1, spelled out for you, find the vector's direction angle from the positive x-axis. So that's down here. So if this is 30 and then that's 90, we're going to do 90 degrees plus 30 degrees. So that's 120 degrees. We already know the magnitude is 20, so our last step is to plug it in. So we get v equals 20 cosine 120 degrees I plus 20 sine 120 degrees j. Then we're going to do our 120 degree angle, label it. So it's 20. All of cosine 120 is negative 1/2. And then we still have I. And all of sine 120 is root 3 over 2. And then we have j. So our vector is going to be negative 10I plus 10 root 3j. Okay, well, let's try it one last time. This is the last one right here. It says the jet stream is 60 miles per hour. So that's our magnitude right there. Whoop, let me put that in proper notation. Express per hour in the direction. So direction is north, 45 degrees east. So this is 45 degrees, and then it's going, this length right here is 60. And then it wants us to write the vector. So we go 60 cosine 45 degrees I plus 60 sine 45 degrees j. 45 degree angle, root 2 over 2. Some of you don't even need to draw these anymore because we've done it so much. That's great. Way to make the pattern in your brain. If you don't need to draw it, don't draw it at this point. So then we get the vector is 30 root 2. Oh, did you see I forgot that I and j? That's a big no-no. So 30 root 2I plus 30 root 2j. And that is it. Alrighty.